All right, so continuing on with what we finished up with yesterday. So yesterday we ended with this example 3. We came up with the recursive formula for it. So just as a quick review, for a recursive formula, we are going to state a pre-existing term, I guess you could say, and then our recursive formula has to use the preceding term or terms. In this case, we can rewrite this as just using the one preceding term and then adding 2 times the number or by the term value. Now, we were not able to write an explicit formula for this just yet because there's not a common difference and there's not a common geometric ratio. And the way that the pattern works is what's called a higher order difference. And that's where we're moving on to the second part. So we're going to write the explicit formula for that, but it has to be in a higher order format. All right, so what I mean by that is arithmetic sequences are first order differences. And whether or not you recognized what we were doing, we were actually writing the equations of lines for those. So in our arithmetic sequence, we would have a sub n equals the first term plus the common difference, or excuse me, plus the number of terms minus 1 times the common difference. Well, in order to write it the explicit formula, we had, I'm just making up something, you had like 3 plus whatever the number of terms are, maybe the common difference was 2. So when you distribute that, well, what do you get? You get something that looks like a linear function. So you'd have 2n plus 1. That's the equation of a line. Y equals mx plus b. All right, well, what we're going to have are second level differences. And that's what was on the case for our previous problem. So in that previous problem, again, our sequence was 2, 6, 12, 20, and 30. All right, and we have a second level difference, and I kind of pointed that out yesterday. So the first time we go through and subtract these, there was not a common difference. So the first time I subtracted this, I got a 4, then a 6, then a 10, just kidding, then an 8, then a 10, 8, and then 10. Well, if I take the differences again, I end up with the common difference now. So hence a second level common difference. So instead of having things in terms of a linear function, dun, 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 yes, they are in terms of a quadratic function. Second, quadratic, second. All right, so we are looking to write the equation in terms of this. A sub n equals a n, it's not sub, it's just a n squared, squared, plus bn plus c. Look like a quadratic function because that's what it is. It's a quadratic function. All right, well, how are we going to make this work now? Let me go to the next slide so I have more room here. Okay, so again, bringing back what I had, rewriting on my previous slide. So I had a sub n equals a n squared plus bn plus c. All right, well, we're going to use this in the same way because once again, I keep forgetting to write down the, okay, so I got 2, 6, 12, 20, and 30. All right, so what I do know is I know the term numbers. I know a sub 1, I know a sub 2, I know a sub 3, I know a sub 4, and I know a sub 5. Okay, well, I'm going to use that in my problem. So what we're going to do now is take and use those terms in relationship to this value. All right, so a sub 1. Well, what's a sub 1 look like? Well, that's replacing the n. So I would have a n squared plus b n plus c. Okay, well, how about a sub 2? Well, now I'm plugging in a value for the n of 2. And then I have a sub 3. I'm plugging in a value for 3 for the n. Well, what do I know? I know whoops, meant to be a highlighter there. I know a sub 1, a sub 2, a sub 3. They're right there. A sub 1, a sub 2, a sub 3. So we're going to use a substitution for those. So now I'm going to substitute, get rid of those, and let's substitute those in. A sub 1 is 2, a sub 2 is 6, a sub 3 is 12. All right, well, let's clean this up a little bit. Okay, so what I have here is, well, 1 squared is 1, 2 squared is 4, 3 squared is 9, and then I have just b, 2b, and 3b. All right, so I'm just going to clean this up a little bit. Boop-a-doo-doo-doo-doo-doo. Magic eraser gone. All right, so what I'm going to have is 1a plus 1b plus 1c. Now remember, it was a 2 squared, so this is going to give me 4a plus 2b plus c. Then I have 9a plus 3b plus c. And I'm wanting to be able to come up with an a, b, and c. How am I going to do that? Let's think. What have we used before that makes solving systems easy? Oh, good job. All right, yes, we are using a matrix. Ta-da. All right, so I have 1, 1, 1, 2, 4, 2, 1, 6, 9, 3, 1, 12. And remember, that was our augmented form. Type that into your calculator. I like my reduced row echelon form. Boopity boopity boppada bop. Get my answers when I plug it in to solve, and you should get a equals 1, b equals 1, and c equals 0. All right, so we know our A, we know our B, and we know our C. Here is the model that we're using. So you just have to plug it in. So the explicit formula for this is A sub n equals, well, the A is 1, so we get 1n squared. The B is 1, so we get 1n. And the C is 0. So there is our explicit formula. We have A sub n equals n squared plus n. That's how we are going to get from one term to the next. So if I wanted to find the fifth term, which would be 30, so I plug that in. 5 squared is 25. 25 plus 5 is 30. If you wanted to find the 100th term, you'd plug that in, and we, voila, can get our answer. All right, so one more example. We are doing a higher order sequence once again. So let's take a look at the next example. All right. So a little clue there, guys, when it says higher order, higher order, ta-da, probably, need to check for differences between more than just the first set. Okay, not sure what's going on with my screen here. I'm going to pause it because I need to fix that. All right, so I hopefully was trying to fix my screen and decided to have a Rice Krispie treat while I was trying to fix that screen. So I think it started on accident. So I apologize, guys. All right. So we got our higher order difference, or higher order definition for this. So once again, if I take a look at my first set of differences, I have 12, I have a -2, I have a -10, I have a -12, and I have a -8. Now remember, it is 12 minus 0, 10 minus 12, 0 minus 10. That's how you're finding the common difference for that. So now we're going to do this again. It's a -2 minus 12, so that's a -14. A -10 minus a -2, that's a -8. We have a -12 minus a -10, that's a -2. And lastly, we have a -8 minus a -12. That gives me a +4. Still not a common difference, so let's try it once again. -8 minus 14, that's a +6. -8 minus 8, that's a +6. And a 4 minus a -2, that's a +6. So you know what we have here? We have a third order, or a cubic order. So what that means is that that's going to be written in the form of a cubic, where we would have a(n) cubed plus b(n) squared plus c(n) plus d. Yes, we have a 4 unknown system is what we are looking to use for this. All right, let me get rid of this, give myself some room to write on. All right, well, again, we know a sub 1, we know a sub 2, we know a sub 3, we know a sub 4. So we're plugging those into our formula. So a sub 1 would be equal to a plus b plus c plus d. A sub 2, okay, so once again, I'm plugging the 1 in for this, so that's why it's just a, b, c, d, because 1 cubed, 1 squared, 1, and then nothing. All right, well, now I'm plugging in a 2. So a sub 2, that means it's 2 cubed. So that's going to give me an 8a, 2 squared. So that's going to be 4b, 2c, and d. The third term, I'm plugging in a 3 in for n. So that's going to be 27a plus 9b plus 3c plus d. A sub 4, that's going to be 4 cubed plus 4 squared. That looks really sloppy, sorry. Plus 4 squared plus 4c plus d. All right, and once again, we know a sub 1, a sub 2, and a sub 3, and a sub 4, so we're going to plug in those values. So a sub 1 was 0, a sub 2 was 12, a sub 3 is 10, and a sub 4 is 0. And then we boopity boppity boop, use our system, or excuse me, use our matrix. So we got 1, 1, 1, 1, 0, 8, 4, 2, 1, 12, 27, 9, 3, 1, 10, 64, 16, 4, 1, 0. RREF it. And you should get A to be 1. B is negative 13. C is 44. And D is negative 32. So lo and behold, ta-da! We get our explicit form of this sequence. So it would be n cubed plus, or actually minus 13n squared plus 44n minus 32. Dun, dun, dun. There we go. All right. I probably would have never figured that out. That last one, you may have been able to figure out that explicit formula without doing the second order definition for it, but this one I for sure would never have been able to just come up with that off the top of my head. So that is how you find a higher order definition. All right, so your homework, if you want to practice, you can try these pages, page 605. Definitely give these are some extra recursive problems to try. So give those a whirl, and then you can check my answer key. And then you're going to have a skills check that's already in there. So when you're ready to go with that, give that a go. And then tomorrow you're actually going to have a review sheet, and you will have a quiz over this material next week. All right. Talk to you guys later.